Okay, in today's lesson, we're going to use everything we know about solving multi-step equations to solve multi-step inequalities. So we've been working a lot with these concepts. Remember, in this case, we're only going to have a variable on one side, even though the slide says or both sides. We're going to save that for later. Let's get started. So when we do this, and you don't have to copy these down because you should be well aware of the steps, we will simplify. Remember, we need to get rid of parentheses, fractions, decimals, combining like terms, etc. You will undo addition or subtraction first. Then you will undo multiplication or division. Don't forget to reverse the symbol if multiplying or dividing by a negative. Remember, there are no equal signs in inequalities. The inequality symbols read differently forwards and backwards, so it's going to be real important to keep track of that variable. Then you're going to check your work. And I won't require you to write down the steps of checking inequalities, but I do expect that you take the time to understand and check to see that you did it right. So let's try a few of these. In example 1, we'll have A and B. For A, let me get a color here that'll show up. Let's do a bright yellow. All right. For A, we're going to, it's a two-step, right? So we're going to undo the subtracting 4 first by adding 4 to both sides. Okay, remember that what you're using to undo the addition subtraction has to be the additive inverse, meaning that the side with the variable, and again, if you need to put the dotted line down, has to be 0. So do the math. Negative 3x and 14 plus 4 is 18. Second step here is dividing by a negative 3. Now this had the less than or equal to symbol. When we divide by a negative number, we know that we're going to reverse the symbol and it will be negative 6. To graph it, and I will be asking you to graph these, it will be a solid circle at negative 6 and go to the right. So you could do a couple different numbers here on your number line. Let's take a look at another one. Another two-step equation. This time the variable's on the right-hand side of this symbol. So we have 7 minus 2t. Now, a lot of kids will look at that and say, oh, I'm undoing subtraction. I need to add 7. But again, it's a positive 7. If I add 7 to the right-hand side, I would end up with 14. Remember, my goal is to get rid of the constant. I need to subtract 7 to make it 0. All right. So 5 minus 7 is a negative 2. That will be less than a negative 2t. All right, and then I'm dividing by this negative 2, which is the coefficient. This becomes a positive 1. My symbol will flip. Okay? And remember, the variable is what we're graphing. So when we graph this, I could put a couple numbers here. It will be an open circle and it would go left. And if you're not sure why it goes left, read it left to right. 1 is greater than all numbers that replace t. So 1 is the biggest value, okay? Or in this case it's not, because it's not included, it's not, but it's the starting point, right? That's the point of reference, and the open circle tells us it's not included. If you read what the variable sees the pointed side of the symbol, and t would be less than. So you could also, at this stage, rewrite it to be these. Both of these solutions have the same graph because the variable sees the same side of the inequality symbol. Oh, here comes the solutions so we can check our work. All right, let's continue with some more two-step equations. In this first case, we want to, the variable is on the right-hand side, we want to add 23 to both sides. All right, negative 8 plus a 23 is going to be a positive 15, and that's going to be less than 5n. We are dividing by a positive number. No need to flip the symbol. So 3 becomes less than n, or n is greater than 3. A lot of times having the variable on the left makes it easy. to see which way the arrow will point. It's open and it points right. This next example, we have 5k plus 12 is less than or equal to 2. So we want to subtract 12. It's on the same side. So 5k is less than or equal to a negative 10. We're dividing by a positive number. We do not flip the symbol, but it is a negative 2 for our solution. When we graph this with the variable on the left-hand side of the symbol, makes it really easy to see. Put a couple numbers down. And it goes left. Now, you know, so far we're getting some nice, neat whole numbers or integers. However, decimals, fractions can be graphed just as easily. All right. Let's try another example. These are going to contain parentheses. I'm going to go ahead and put both of these up here for you. All right. Couple things. If you're trying these. The first one, I noticed that in the solution that shows at the bottom, they had a less than or equal to symbol, so I wanted to make sure that that was part of the problem. All right, when we have the parentheses, we have to simplify those. We are distributing a positive 2. So 3p plus 2p plus 2 times 7 is 14 will be less than 9. We can combine the variable terms, so we have 5p plus 14 is less than 9. So if we subtract 14 from both sides, we get 5p is less than a negative 5. Okay, and then we're dividing by a positive, which does not change the symbol. Okay, does not change the symbol because we're dividing by a positive. It's very easy to see that at negative 1 it would be an open circle and point left. That would be to negative 2, to 0, things like that. All right, let's look at the one on the right. We are distributing a negative 2 inside the parentheses. So here's our, bring down the 15, bring down the symbol. 5 stands alone. Negative 2 times 4 is negative 8m. Negative 2 times 7 is negative 14. Then we have some like terms, 5 and negative 14. So let's simplify those. A 5 plus a negative 14 become a negative 9. So we keep our negative 8m minus 9. Now we're ready to simplify. See the variable, we want to add 9 to both sides. Okay, 15 plus 9 is 24. It's going to be less than or equal to negative 8m. We'll be dividing by negative 8. We'll get negative 3. We divided by a negative, which flips or reverses the symbol. Okay, so we have negative 3, which is greater than or equal to m, right? That also means that m sees the less than or equal to side of the symbol. What's going on here? So if we're going to graph this, we have negative 3, a couple numbers around it. It's a solid circle at the starting point, and it will point to all the numbers that are less than or equal to negative 3. Lots of steps, I know. All right, one final example. In this case, we're distributing a positive 3. So we have 8 is greater than 15 minus 3b plus 2. Okay? So the 15 and the positive 2 can be combined to be 17 minus 3b. And then we'll subtract 17 on both sides, because we need this to go to 0. And 8 minus 17 is a negative 9. If we're subtracting 17, it's going to be greater than negative 3b. So if we divide by a negative 3, what happens to our symbol? We have a positive 3 is less than b, which we could write as b is greater than positive 3. What does that look like on a graph? Positive 3 here, a couple numbers around it, an open circle at 3, and it goes to the right. Okay? We're going to summarize everything that we've done so far. Okay, so we're solving multi-step inequalities just as you will solve multi-step equations. We simplify, meaning add like terms, perform distributive property, and so forth. Undo addition, subtraction, undo multiplication, division, and reverse the symbol if needed. It would only be needed if multiplying or dividing by a negative number.